Greetings. Welcome to the second video of the series of Basic Electronics. In this video, we will learn how series and parallel configuration differs, and see few interesting events happening in our circuit. The current in a series circuit is always same, while in parallel circuits, it divides itself, depending on the resistance in the branches. Let us take an example for series configuration. Now, we have two LEDs connected in series. Do both of them emit the same amount of light? Let's measure the current through the circuit. Choose an ammeter, or a multimeter set to measure current.
Here we go.
When we run the simulation, we can see the two LEDs working perfectly. With two multimeters, we can see that the current through the first LED is the same current that exits the second LED, which proves the current in a series path remains intact and unchanged. The current is high enough to make the LEDs glow. To make things interesting, let us connect a third LED. We can see the current is quite reduced, and none of the LEDs glow. All components possess a small amount of resistance, which includes the LED. By adding the third LED, a little bit of resistance is added to the circuit, so the current is too low to turn LEDs on. To increase the current, we can either increase the voltage or decrease the resistance, or both. Let me decrease the resistor value to check if the current increases. And yes, the current increased. Now we can see that all the three LEDs glow, through which the same current flows. In order to make components parallel, connect the ends of both components to each other. We have a circuit in which two LEDs are connected in parallel. Let's run the simulation. The LEDs didn't glow. In order to understand this, let's connect the multimeters. We can see that the total current has divided in half in those two branches, which reduced the current flowing through the LEDs. They are just like two paths. Some current goes one way while the other goes around, depending on the resistance the branch offers. Around 5 milliamps is required to make the LEDs work, but the total current is divided. This is why the LEDs didn't glow, while it worked in series, as the current was never divided. In order to make them glow, let us lower the resistance value. We can see the LEDs glowing, since the current has increased in both the branches. Now, let me replace an LED with just a wire and see what happens. The LED doesn't glow. We can see no current flowing through the LED. It's because the current chooses the path of least resistance. That made the current to choose the path of the wire. Let's look another example. So far we have been using blue LED. Notice the forward voltage, VF for the blue LED, and also for the red LED. The blue one has higher forward voltage, which means it offers quite amount of high resistance than the red one. If we connect the red LED in parallel with blue, the current chooses the path of least resistance, which is the red LED. Let us see the breadboard equivalent to check these. Let us look at the series circuit. Connect negative of one LED to the positive of the other. Likewise for many LEDs as you wish. This forms the series circuit. You can observe that all the LEDs glow, but not so brightly as expected. It's because of the LED's resistance. As I remove the LEDs, one by one you can see them glowing brightly. Let us look at the alternative equivalent circuit with wires for clear vision. Some LEDs may look brighter than the others. It's because they differ in their configuration. But the same colored LEDs emits the equal amount of light, proving the current is same. For parallel configuration, connect the two ends parallel to each other. For LEDs forward biased operation, connect both positive ends of LED to positive of battery, and negative to negative. If one LED is removed, we can see that the other one increases its brightness as more current flows. When a wire is connected parallel to the LED, no current flows through the LED. Since wire has least resistance, current chooses the wire's path. Thanks for watching. Stay tuned for more.